A few words about me. I'm a software developer. I'm mostly interested in Java and other languages running on Java virtual machine. I work for Okado Technology Kraków. We have several teams that use contract testing in slightly different ways, and I would like to share you some of those ways later. Short agenda for today. So first we will talk why do we need contract testing, what are contract tests. Then we will take a look at one framework that allows us to write contract tests. It's called Pact. Then we will talk about possible use cases. And finally, we will take a look at an alternative called Spring Cloud Contract. So this is how the systems we work with today look like. They consist of many small parts. There are lots of connections. And the problem with this architecture is how do we know this all works as the whole? And suppose we are running a grocery business, and here are just two applications we develop. So in grocery business, we have a warehouse when we store goods. Okay, so trucks are arriving, storing something, and we want to plan the work we do in this warehouse. So imagine we have some water carrots, and we need forklifts to move those from one place of warehouse to another. And we need to plan how much forklifts do we need for a given day. So we write an application called planner application. It will ask the other application, for example, how many goods are planned for tomorrow? And the other application will answer, okay, we have apples, so many, and water, so many. And the planner application will know how much a forklift can take, and will calculate how many forklifts do we need. So now let's test that those two applications can work with each other. So one way to do it is to mimic production. So we will create a test environment called, for example, CIT, and deploy all our applications there. So this approach is called like end-to-end testing, integration testing. There are different names, but the idea is that we have all services deployed there, and we run our test against those real services. So one problem with this approach is that it's slow. So we get network latency, not only between those two services, but also imagine that our supply system needs to ask another system before it answers to the planning application. So now we have multiple network latencies added. And also, this approach is slow because usually we cannot run sets concurrently. So say that we have a bunch of changes in version control system, and we want to test if they work or not. So we deploy them to the test environment, run some tests, and in the meantime, as those tests are running, we have another bunch of changes. But we need to wait for the other tests to finish, because usually we have only one testing environment, and if we run two sets of tests, they will interfere with each other. Those kind of tests are unstable, because there are so many things that can break. We can have temporary network problems that break all our tests, and it's not our fault. Or a different team may deploy a service that breaks backward compatibility. And we want to test our services, but we cannot because somewhere in the dependencies, something broke. And yeah, we can do nothing about it. And finally, when those tests break, they are really hard to understand. So we may have logs in another service. We need to find those logs, understand what happens there. The service is written in by another team in a different technology. We may not understand this technology at all. So we end up asking the other team, hey, what do you do? Is this a correct state? Is this your fault, our fault? It takes time to understand. So how can we improve this? We want to give teams more autonomy, make them independent of other teams, so we can mock dependencies. So if we have services like this one connected on production, we will do on our system, on our testing, during our testing, we will substitute one of those services. So say I'm in planner team. So when I write my tests, I substitute the real supply system with a system much simplified that I control. So my planner application will call the other system, get some prefabricated answer, and then I will know if my system can handle it or not. And similarly, if I'm in supplies team, what I do is I make a system that can call my system like the planner application does. And this is how I find out if my supplies application is able to handle those requests or not. So this way, if we use this approach, okay, we get independence. Our team is not so dependent on other teams. And usually those tests are also fast. But what happens? Test on one side pass, test on other side pass. But when we connect those applications to each other, maybe on production, it breaks. Because two tests on both sides use different assumptions. So for example, we have one L because one side is using British spelling, and two L's because the other side uses American spelling. I think you have probably seen such a case in your life. So how can we fix it? How can we have tests that are slow, that are fast, but don't have the problem, like silly problem that we made a spelling mistake and it breaks on production? So the idea is to have a single source of truth. What is right, what is wrong, and then we will have both teams have tests created automatically. We don't want those teams to invent their own tests. We want this single source of truth to dictate how to test. And we will call this single source of truth a contract between those services. So in the world of contract testing, we call the side that makes request a consumer and the side that accepts request provider. So client and server are sometimes ambiguous because an application in the microservices world is usually both a client and a server. So let's stick to consumer and provider. This is a standard terminology in the world of contract testing. Let's see how we can make it. How can we code it? So I have an application written in Kotlin that is this planner application. I also have the other parts, so the supplies application. It is also written in Kotlin. So now this application has some business logic. That's why I wrote it. Details are not important. So here I do some calculations based on the input. So this is the input. I get those data over the network from the supplies application. And those data, I have a list of supplies. And for this example, my supply has 3 fields: number of items, their total weight, and the status. And the status can be active or canceled. So this is my business logic. And to get my data over the network, I need to handle communication. And usually when you write such applications, we have some abstraction over the network communication. And this is the case also here. So I have a client application that does a HTTP request, passing some parameters. Then if everything is all right, I deserialize the HTTP body into objects in my language. Okay? And now I can send those objects to my business logic. So how can I test it? In Pact, I write a simple unit test in my language. So here for Kotlin, I'm using JUnit, a very popular unit test framework for JVM, with some additions from Pact framework. So what I'm testing my client class. And this client class needs to connect to something. And what Pact gives me, it will set up this fake server that will answer with pre-populated responses. So my job is to set which port this fake server will run on, and then I configure my client to use the same port, 9051. So here is the setup of my test, and now I can have test cases. So in the case of Pact, each test case consists of two methods. I have an actual test method that does some action. Here I call my Kotlin code with some date. And then I have a second method that is connected. And this is a range part. So I configure this fake server. And the framework gives me a DSL. So I'm now assigning a description to this interaction, say what is the endpoint, so what parameters are expected, and if the fake server sees matching request, oh, by the way, the method should be get, so if this fake server sees a matching request, I configure it to respond with HTTP 200, and I have a DSL for configuring what will be the response. So here I say that in this case, I want the server to return an array with one object with a field status with value cancelled. And I also have a second test case where I see what happens when I do a wrong request. So I pass a value that is not a valid date. And my intention is that the server responds with HTTP 400, not 500, because they have a null pointer or something. I want them to nicely tell me that I'm doing a bad request. Let's run it. Okay, so what happens? Here in the first test case, I was calling my client. It did some requests, so this fake server logs that it receives a request. The request is matched, and because everything is correct, the fake server is generating a response with status 200, okay, 200, and the body is as I configured, an array with one object with status cancelled. And now in the second test case, I was expected 400, and I'm getting 400. So what happens after I run this test? In a directory of this project, a JSON file is generated as a result of running this test. And this JSON file is my contract. So this is a representation in JSON of the logic I have just written in my Kotlin test. And this is JSON, so it is platform independent, and I can share it with the other side, with the supplies application, with provider, and it will be used to enforce that the communication method is understood in the same way on both sides. But why do we write tests? Do we write tests for the pleasure of writing tests? No, we write tests to catch some errors. So maybe we'll see if we can catch something useful. Let's break something. We'll break our client. So let's suppose I'm stupid and I forgot to pass parameter. So my client is making nonsense requests. Okay, I get a failure. And what happens is I get an exception saying this is an unexpected request. My fake server was not configured for this case. And if I check the logs, I can see there was a mismatch. This was expected. And actually what happened is that query parameter day was missing. Yeah, good, good. We found an error. No enthusiasm here. Let's try something else. Let's do the infamous spelling mistake we have seen at the beginning. Okay, double L. Let's use American spelling. Okay, so my test expects one L and my code has two L's. Failure, good. So what happened is, okay, so the deserialization in my Kotlin code failed because from the server I get string with one L. This is in the HTTP body. And my Kotlin code has an enum that can handle only active and cancelled with double L. So again, I'm protected against this mistake. So now that I have the passing test, what do? I will take this JSON file and send it to the other side, to the provider. And here what I do, I'm using package manager for Java. I'm using Maven packages to pack this JSON file. Maven dependency resolution will assure that it's published to some place where the other side will be able to get it. So let's go to the other side. The other side is also an application written in Kotlin. It uses Maven dependency resolution to download this JSON file. So my application has server running, very simple one, just one endpoint. And what I do is I have a fixed list of supplies I will always return. So let's see if my server fulfills the contract. And this is my test. Again, on the provider side, the contract test is just written as a normal unit test with some additions from the framework. And you can see it's much, much shorter. Why? Because we don't have any test cases. All test cases are in the contract. So my job is different than on the consumer side. My job is to execute the contract. So I need to provide how this contract is found. So because of the Maven dependency resolution, I have the file on my class path. So I say the contract is on class path. And then I need to inform Pact, who am I? So I am supplies application from this contract. So Pact does some matching of interactions, and I need it to match interactions to be executed here. And now I need to start a server and inform the framework how to find this server. So here I inform Pact, this is a class from Pact, that my server will run on port 9052. And I start my server on this port. So let's run it. Two test cases. So on the consumer side, we had 4 methods, but they were creating 2 test cases, and I also have 2 test cases on the provider side. One case, this one with 1 cancelled supply, passes. So what happens here is the framework is making a request defined in the contract. So it does a GET request with those query parameters, and my server returns a response. The Pact framework is logging what was received, and it does some matching. It checks things from the contract. So it checks the status code, it's okay, body is okay, the test passes. Now the other test case, the one with malformed date, it fails. And why does it fail? So the contract expects HTTP 400, but my server is returning 200. And why? Well, actually, I'm not handling the query parameter at all. So it's like with TDD, I'm able to catch a feature that is not implemented. Okay, let's fix it. It's very simple code just to make the contract pass. Success, success, all right. So now, this should be better than the end-to-end tests, so it should be at least faster. As you watched me running those tests, you may guess that this is quite fast. So I was able to run 200 test cases per minute on the consumer side and 2,000 test cases per minute on the provider side. So this is like a more complicated unit test using some Spring context or something like this. It's as fast as you can start and stop your network stack, as you can handle your database queries. It is not a bottleneck on your testing. And by the way, why the difference? Well, on the consumer side, as your test is run, it in the meantime generates the JSON file with contract. And it does some merging between different interactions. So this is why the test is a bit slower. How do we work using this kind of tool? So when we need a new feature, we start from the consumer side. So we say, OK, I need to call an endpoint and get some data. So I write a test. And then I see, OK, the test passes. So I'm able to make this request using my code. And then can I use this data for something useful? Am I missing some fields? Do I need more fields from server? Or maybe I have initially requested too many fields, so I decide how do I really need to communicate with the other side. So if I'm confident, yes, it will work for me, it will be useful from a business perspective, I send the contract to the other side. And then the provider team goes, they use the new contract, the unstable one, and then their test should fail because they don't have it. They work on their code, add a new feature, and the contract passes. So they upgrade to the new version of the contract, and start using it in their CI builds, and we have a new feature finished. So what is interesting here is that we can work on a business feature on the consumer side where the feature is needed without waiting for the provider team. So they may be busy, they may say, yeah, we can give you this endpoint in 1 month, and you need to have a demo for your product owner now to see if it makes sense or not. And you can do it because you have this fake server that will send you some data. And in the extreme case, there may be no provider yet. Maybe we need to build the provider system, but our recruitment is stuck and we will have those programmers next month. OK, no problem. We will implement it. We will have a contract. And when they will start implementing, we will be sure that the communication method is the same on both sides. If we work with contract tests, we need some way of sending the contract to the other side. And yeah, we could use something really, really simple, like taking the file from our disk, attaching it to an email, and the other team will commit it to Git, and it will work. But usually, we need something more robust, more automated. So one way to do it is to use the favorite package manager of your platform. Like for Java, this is Maven. So what we do, we get this JSON file packet and let the package manager do its job. So we will get versioning, we will be sure that it is downloaded, we will get some retries, and so on and so on. Because contracts can be versioned. We can have unstable version, snapshot version, stable version. This is a task in which package managers are good. So we can use this approach. And finally, there is a dedicated tool. Pact creators have a server called Pact Broker, and it is able to store contracts from multiple systems. And it gives you some additional nice features, like you can have visualizations, how your systems connect. It can help you understand how this works. It needs some setup, so first you need to host it. It needs a storage, so you need an SQL database like PostgreSQL, but it's prepared as a Docker, so it's not so hard to set up. All examples before were using Kotlin. It's a JVM-based language, but actually Pact is a cross-platform tool. So it started as a Ruby project, and now it has implementations for many languages. Even if you cannot find your favorite language here, there is a possibility to use Pact and use contract testing. Just Pact can be used for any language on the provider side. How is it possible? If you remember how we implemented the contract test on the provider side, we weren't writing anything, we were just making sure our service works on a pod. So Pact creators have a Docker image that can read the contract, and it will fire requests in the way defined in the contract on our service. And our job is just to set up something running on a pod known to this Docker image. So since Docker is platform independent and you can have HTTP server written in any technology you want, this makes Pact usable for any language on the provider side. Also, you can have multiple consumers having contract to a single provider. And Pact will execute all of those contracts on the provider side simultaneously. And imagine you have contracts to all of your provider applications. And now, if you want to remove a field from an object you return, you remove it, check if your tests pass. If they pass, it means that no consumer is using this field, and you are safe to remove it. And you remove it. So this gives you high confidence how applications around use the one you develop. You don't need to go around, ask people, you have it automated. So tests before were using no assertions. And still we caught some errors. So what we were checking that our client code is able to make a request and that our deserialization works. So, okay, you can do it, but usually when we write tests, we write some assertions. And one way to do it is to make assertions on the fields. So we get those objects deserialized from the client and check that fields are okay. So we will get a bit more confidence. We will know that the mapping between HTTP body and our objects is correct, but there is another way. So we can connect business logic with the client. And this way, we have contract test providing values to our client through the fake server. Then our client provides input data for our business logic. And we test what happens in the business logic by checking the output of business logic. We don't check the objects in between, the fields, and so on. So both approaches are correct. There are people who prefer one, people that prefer another. I like this one, and I hope to show you why. So imagine we don't use it, and we write the contract test just to check the client. So then, apart from the contract test, we will need another unit test, a unit test from the business logic class. So this is it. We have a hard-coded list of input to the business logic, and we check the output of the business logic. And now imagine those two tests pass. And this is the resulting implementation, a simplified fragment of it. And okay, this implementation passes our tests, But the problem is that the original requirement was that cancelled supplies are not counted. So what went wrong? How could it be? Any ideas? What was our mistake? So we had poor quality test data. All our supplies were active. And if we tested client code together with business logic, we would need only to think once about the test cases, okay? Because those test cases are in the contract. And if we tested both classes together, they will use those test cases. So I think it's nice to take this approach. Now imagine we are experienced in contract tests. We like them, we know how to use them. We write lots of test cases. And now we come to a problem that we have two test cases that require contradicting things. So in one test case, we want to have one supply, and in the other test case, we need the fake server to return two supplies. And how do we code it? Remember, what we write in the contract will need to be executed against the provider. We will need to set up our provider in test context so that it can sometimes return one and sometimes return two supplies. Remember, we had this hard-coded lists of supplies. So one way to do it is to play with query parameters. So we can have 23rd December, meaning one supply, and 1st December, meaning two supplies. And it will work. We can code the provider side that it matches query parameters and returns different things. But you know what? I think it's really cryptic. What's so special about 1st December? And sometimes you are not able to use this approach because you have an endpoint that doesn't have any query parameters. And sometimes we need a non-admin user returned, and sometimes we need the fake server to return an admin user. How do we do it? So in Pact, the method to achieve this is called state. So state is a textual information attached to an interaction, to a test case. And the provider side has access to this description and can act accordingly, can put the server inside to some other state. So let's see how it works in practice. So I have a test using state. This is a third test case, different from the ones you have seen before. And now I need two supplies to be returned, one cancelled, one active. And this is my state. So this is a line given, and this string will be passed to provider. Now let's publish it. And execute. And what happens? What happens is we have third test case, it fails. It fails with a message saying that I need a method annotated with this annotation. So it's quite nice because the failure of the test shows me the code I need to use. So let's use it. So I need a method. And now the framework will find this method when it sees that my contract has this state. And it will call the method before it starts interacting with my fake server. So now I implement what is required. So I set the server into the state, Okay. The first one should be cancelled, and the second one will be active. Now, let's see if it works. Now, I don't have an exception. It is yellow. I get an failure of assertion. So what happens is I was supposed to have 4 here and 20 here because the contract said so. Now let's rerun it. And it passes. So yes, we handled state. I don't know if you are proud of what we have just done. Maybe you don't like the way of using it. So if someone here doesn't like the way of handling, you can raise your hand. Nobody? I really don't like it. I hate it. I hate it, you know. You have seen that I have used 13 and 14 because I didn't know that it was so important. I didn't know that contract says 4 and 20. This string did not inform me about it. So yeah, I could write it in the string on the consumer side, but how long string can be? 2 lines? How can I handle 2 lines of text? I will become a human parser. A computer should parse a string, not me. Now I had to parse this string and hope that I understand it correctly. And the other problem with this approach is that if you have like 30 test cases and each test case has some state. Now on the provider side, I need 30 methods. They will be very repetitive, something like this, lots of coding, not very creative one. And also, if you have those strings and you need to change something, your provider side will fail because it matches the string. Okay, so if I change like cancelled here and active here, yeah, my method will work. I will just need to flip it, but it will fail. So every change causes a change in provider, and there's a better way to handle it. It's called parameterized state. So how does it look like? I won't have a different state for each test method, for each test case. I will have a generic state. I will call it supply. And I will inform what does it mean in parameters. So I will have a parameter status. The second one is active. And now I can specify, okay, I need count 4 and also total weight is important here. And the first one was supposed to be cancelled. And here I can say, yeah, it's not important what is the weight and count in this case. And now on the provider side, I won't run it because we don't have time, but I will just show you how it simplifies the provider side. So I won't have 30 methods, I will have 1 method. And now the framework will pass an untyped map to my method, and I could use it like this. Okay, so this is a map. I take something from it. I can use some defaults if the map doesn't contain. So in the first case, I had not specified count, so I can use some default instead. And I think this way of handling state is quite powerful. In my project, we are also writing something like this, a supplies application, and when we connected to it, we wanted the application to filter results by day. But it wasn't simple filtering like midnight to midnight. It was something like 6 p.m. to 6 p.m. So we had a test case when we have multiple states. Each state was a supply, and we have some supplies before the time window, some inside, and some after the time window. And our contract test was checking if the returned supplies are only those inside the time window. And more, we also thought, okay, what if we change the clock? So there is a day in some countries when we turn our clock backwards or forward, and then what happens if we match incorrectly? So we had a test case where all supplies were on the day when the clock is changed. And this test case was able to find an error in time handling code on the provider side. So I need you to remember that contract testing is not just for checking that you have this field and that field in JSON. You can also test more interesting scenarios. Okay, so if we have a test case, we usually don't want to specify all details. So like here, what is interesting for us is just this field status with value cancelled. And unfortunately, while we want to keep our tests readable, our code may not agree to it. And here we get a deserialization error because our Kotlin code assumes that count is required. So how can we handle it? Yeah, we can specify that the server needs to also return a count field. So yeah, on the consumer test, we will get this 50. Our deserialization will work. But the problem is that we also require the provider side to return 50, and only 50. So we cannot write provider that is like using random numbers for fields that are not interesting. So we need a better way to do it. And we can use a different method. Instead of number value, we can use number type. And here, this 50 is just an example. It will be used on the consumer side. This fake server will return it so that our code will work correctly. But the framework won't check anything on the provider side. Well, it will only check that this is a number. And we can go further. If we have 20 fields and we are just interested in one field, we can specify those 19 as just field names. And Pact framework will set random values to those fields if it's OK for us. And then we will have a readable test. And there is more we can use, like regular expressions to check that parameters have correct values, and so on and so on. But let's go to a high level. How can we effectively use contract testing? So one way I have seen in one of teams in my company was that they were using contract testing between their front-end and back-end application. Remember, this was a single team. These two were both their own applications, but they said, yeah, when you write front-end, you anyway mock responses from the server. So why don't you use contract testing? So they had experience with contract testing. It was fast for them. And they get rid of problems between backend and frontend. Another natural test use case is when you have different teams. They have services that talk to each other. And if we have contract between them, we don't care about time zone differences. We don't care about language barrier. We don't need to use like Google Docs that are always outdated, where we look for fields that are deprecated or new. We have a contract. It does it automatically. And then I had the case where I had to do a project handover. So I had the consumer part and provider part written by me, by my team, and I had to give the provider part to a different team, a new team, that haven't seen any of the code. And I was afraid that the new team could introduce a regression because they had not enough experience. So we decided to give them regression tests in the form of contract tests. So then they will have more safety because they will be able to make any changes in their service, and the contract test will make sure that they can still communicate with the service on our side. And previously, all my examples were about HTTP communication, and now we more and more use message-driven communication. Fortunately, most contract testing frameworks are also able to be applied for message queues. I won't talk about it today, but it is also possible. And if you use Pact broker, you get some additional nice features. Like you can see how your services talk to each other. Maybe there is no central place in a company that says how many services do we have and which talk to which. You can see how often those contracts are verified, if they pass or not. It can even draw nice diagrams like this, so we can see that our supplies application is called by planner, but also by shop application. And finally, you can serve like something like Swagger. So for each use case defined in our contract, we get valid request and valid response, so we can learn how to use this service by looking at the contract. Okay, enough of Pact. There is an alternative tool that offers some new possibilities. So let's go back to how we work with Pact. We start from the test on the consumer side. It generates a contract. We send the contract over a network. And then on the provider side, we execute automated test that verifies the contract. And now the problem with it is that the most of the work is on the consumer team. And what if consumer team likes contract tests but doesn't want to spend too much time on it? Sometimes the provider team sees more benefit because they have regression tests. They know that they won't break the consumer. And in this case, if this is the case in your team, you may be interested in Spring Cloud Contract, which uses a bit different workflow. Here, the contract is owned by the provider. In Pact, if you are a provider and you want something to be changed in the contract, you go to the consumer team and ask them kindly to make a modification. Now, in Spring Cloud Contract, you own, as the provider team, the contract. You also do the most of the work to set it up. You choose the library, connect it to your build. So the consumer side just needs to run those tests. They don't need to spend too much time working with it. So it may be an advantage if they are not interested in contract tests, but you are more. So we use Spring Cloud Contract. So how it works, you write a contract on the provider side. Now you have automated tests for it. And during your build, stubs are generated. And stubs are definitions of behavior of this fake server. And they are needed by the consumer side because they need this fake server in their tests. So you write, you send those stubs over the network, and the consumer side, what they do, they just run their tests using those stubs, and they get responses you configured. A bit more how it works. So if you use JVM, Spring is a Java and JVM-based project, so the primary use case is for people writing in Java. You write your contract in Groovy. It's a file you commit to your repository. And then you need your build tool to generate tests. And those tests need to be in JUnit 4 or Spark. They currently don't support other frameworks, so if you like JUnit 5, sorry, you have to commit you have to open a pull request to Spring Cloud Contract. Also, if you are a Scala guy and you like Scala tests, sorry, no support for now. So then your build tool, and they currently support only Gradle or Maven, generates stubs. Those stubs are in WireMock format. It's a tool that can be used also standalone. Then those stubs are published to a Maven repository. There isn't so much freedom in the way of publishing contract as with Pact. Spring Cloud Contract firmly uses Maven repositories. And then on the consumer side, you get stub runner from a library from Spring. Stub runner starts a fake server, downloads those stubs from Maven repository, and it can serve responses to your client. And what is funny in this stub runner is that normally how you use Maven is during your build. You download dependencies during your build. And here, Spring Cloud Contract uses it during your test execution. So while your test executes, it downloads dependencies. It's a bit strange, but that's how they do it. Okay, this is for Java. But what if you are a JavaScript guy? You don't want probably JUnit and things like this. So they, since February this year, opened a possibility to use it on all platforms. So you write your contract in YAM, which is completely platform independent. Then they give you a Docker image that you execute, and it verifies the contract on the provider side. It can also publish to Maven repository. If you don't have a Maven repository, so if you are a JavaScript-only company, you probably don't have your internal Maven repository, you can use a specially formed Git repository. And then on the consumer side, you have another Docker image, you run it, and it downloads the stubs and acts as the fake server for your tests. This is how the contract looks like. The syntax is not important. You get some code completion if you use Groovy. Logically, it's the same as with Pact, just the form is a bit different. So while you run it, you get generated test with logic defined in the contract. It executes assertions, and you don't touch it, this file. This file is generated during your build. What you do, this generated file extends a base class. And your responsibility is to write this base class. In this base class, your main responsibility is to start your server. Just like with Pact on the provider side, you start your application on some port and inform the framework about this port. What if we have a case when we need different responses from the server? So Pact handles it with state. There is no such idea as state in the world of Spring Cloud Contract. If you want to have different responses, you divide your contract into directories. Okay, so I have a directory for many supplies and a directory for one supply. What it gives me is that when I run my build tool generates two classes with tests, and those classes inherit from separate base classes. And now I have a base class for many supplies, and then I can set the supplies accordingly, and a base class for one supply. Okay. Our time on this earth is limited, and you may say, okay, those contract tests are nice, yeah, you talked about them, but I'm too busy, I don't have time for them, because I need to write tests for the client code, to check if my requests are done properly. Then I need to write tests, checking that I use correct fields. I constantly go to the other team, ask them what are the currently supported fields, what are not. This takes a lot of time. I need to think about those edge cases. I need to cover. And finally, I don't only write tests for my web layer. Hey, I need to check that also my database queries run correctly. So no time for those contract tests. And my answer is, okay, you need to cover those areas, but why don't you cover them using contract tests? Because if you use contract tests, you have checking if you do correct requests for free. Then also for free, you get checking that you use the same fields on both sides, that you use the same communication protocol. And then you only need to think once about edge cases, about interesting test cases. You think once, and they are executed on both sides. And finally, when you run your tests on the provider side, you can start your whole stack. Yeah, you can mock some dependencies. If you use Spring, you can start a context with database mocked out, but also we can start like with in-memory database. And then you also run your database queries during your contract test. And on the consumer side, you can plug in your business logic to the data from the contract test. So maybe you can write less tests. Maybe you won't need some types of tests if you use contract tests. So this is all for me for today. I hope that you will give contract testing a try with either Pact or Spring Cloud Contract, and you will find your own combination of tests that is for you fast and safe enough. Thank you.